Question 13. Here we have kx squared plus kx plus 2 equals 0, and we're told that that equation has got no real roots. And given that it's got no real roots, we're asked to show that k must be between 0 and 8, where 0 is included but 8 is not fully included. Okay. So, it's got no real roots. What we know is that the discriminant b squared minus 4ac must be less than 0. So that's our starting point. b squared minus 4ac is less than 0. Now, in a quadratic equation, the b is the coefficient of x, so it's the k there. The a is the coefficient of the x squared, so that's that k there, so it's the same k, but it's a different position. And the c is the number at the end, so that's the 2. Okay, so we have k squared minus 4 times k times 2 is less than 0. Tidy that up a little bit. 4 times 2 is 8. And we have that quadratic inequality. So this effectively comes down to a quadratic inequality question. Now if k squared minus 8k equals 0, then we would have k bracket k minus 8k, sorry, k bracket k minus 8 equals 0, and therefore k would equal 0 and k would equal 8. Now what that does is allow us to draw a quick sketch of the graph. K squared minus 8k would give roots of k equals 0, k equals 8. K squared is a positive squared term, and so the shape of our graph would be U-shape. Okay, so what I've effectively just sketched there is y equals k squared minus 8k, where this is the k axis, okay, and that is the y axis. Okay, this is our 0 and this is our 8. Now, the inequality we're trying to solve was this. K squared minus 8k is less than 0. So the k squared minus 8k is equal to the y values. So we're basically looking for where the y values are less than 0. Well, the y values are less than 0 here. And so for all of that region on the graph, the y values are less than 0, which means the k squared minus 8k values are less than 0, as required. Okay, and therefore that region is between 0, and 8. Okay, and because this is a strict inequality here, these are going to be strict inequalities there as well. Okay, so we're almost there. We've justified then that k is between 0 and 8, but doesn't include yet the 0 or the 8. Now, it shouldn't include the 8 according to our question. It shouldn't include the 8, but it should include the 0. So we need to check the 0 separately in a different way. So going back then to our original equation, it was k squared plus, it was kx squared plus kx plus 2 equals 0. And we're supposed to be showing also that if k equals 0, then this has no real roots. Okay. So if k equals 0, then this would give us 0x squared plus 0x plus 2 equals 0. 0x squared is 0, 0x is 0, so the left hand side would reduce down to 2, and the conclusion would be that 2 equals 0. Well, 2 equals 0 is a contradiction. That's one symbol you can use to mean contradiction. Okay, so 2 doesn't equal 0, and therefore k cannot equal 0 either, because if k does equal 0, it leads to a contradiction. So that means the original premise that k equals 0 must be false. So k cannot equal 0 there. Put that together with our inequality that k is between 0 and 8, leading to no real roots, and we have k cannot equal 0, and easier stated. So no real roots when k equals 0, or when k is between 0 and 8. So no real roots when k equals 0, or when k is between 0 and 8 means that there's no real roots when k is greater than or equal to 0 or less than 8 and less than 8. That's required.